To talk about metallic bonding, we have to remember metals have low ionization energy. They have easy time to lose their valence electrons. And in order to describe the localized model, which is you have regular pattern of positive ions, these are your nucleus, and then the electrons are going to be delocalized. They don't belong to any element anymore. They are going to randomly move around. And since these attractions among the neighboring nuclei and the electrons are all over the place, only the positive ions are fixed in place, the electrons are going all over the place. Usually this electrostatic attraction is also known as non-directional. Now this delocalized model yields few properties: conductivity, malleability, being a ductile, and also being non-volatile. Conductivity, since electrons are just simply movement of electricity is movement of electrons. As soon as you connect positive and negative pole of a battery, electricity gets conducted. Malleability, if you take a hammer and just hammer this regular lattice, it will reshape itself and it will just go into different layers, and then they have the same electrostatic attraction. So that's malleability, which you can hammer them into shape. Finally, you can pull it to the point that they turn into fine wires. And they're non-volatile. They have high melting point, therefore they have difficulty to turn into liquid and then gas. They're not volatile. Now, to look at the strength of metals, it depends on two factors. One is the charge of the metal, the other one is the size of the metal. Collectively, they could be referred to as charge density, which is the charge of the ion over the volume of the ion, or the size of the ion. If the charge goes up and if the volume or the size goes down, you would have stronger metal. Now, if you look at group 1, lithium, sodium, potassium, these are soft metals. However, as you go down, you see their melting point decreases. Why is that? Because, for example, in case of rubidium, size-wise, rubidium is much larger than lithium. But they both have 1+ charge. So the charge is the reason why this rubidium has lower electrostatic attraction for the next door rubidium, and therefore their melting point goes down. Now, if we go across the periodic table, for example, if we compare sodium to magnesium, you will see sodium is 1+ and magnesium is 2+. And when you look at their size, this is 102 picometers. So this is size. And this one is 72 picometers. So magnesium has two factors that are going to help it to be stronger metal. One is its charge, which is high, and one is its atomic size or radius, which is small, therefore its volume is going to be small. So that's why you see in case of magnesium, you have higher melting point compared to sodium. Finally, if we look at alloys, alloys are homogeneous mixture of two or more elements. Now, this side, these are naturally found metals such as copper, cast iron, aluminum. Now, if you mix two or more, then you have alloy with different properties that we usually look forward. Brass is one that you should really know, is combination of copper and zinc. You will use it as a shiny doorknob or many other facets of buildings. Now, steel is combination of iron and other elements. Usually you have a trace amount of carbon, and you can put nickel or something and have stainless steel, and you could have carbon steel and many other possibilities. So alloys are mixture of metals with other metals or other elements.